Okay, so for this problem, I'm gonna need to start by just by looking at it. I think what I need to do is make sure that they all have the same common denominator, and then I'll be able to apply L'Hopital's rule to be able to solve for A and B. But first, needs the same common denominator, so I'll go ahead and sort that out on the side. So in order to allow for A to add with sine 2x, I'm going to need to multiply by x cubed over x cubed. And this is going to give me sine 2x plus ax cubed over x cubed. And then to add the term b over x squared, I'm going to need to multiply by x over x. And this is going to give me sine 2x plus ax cubed plus bx all over x cubed. So I'm going to go ahead and rewrite my limit. So from here, you can go ahead and plug in to check for the indeterminate form. And if you get an indeterminate form, then you could use L'Hopital's rule. So I'll go ahead and plug it in. And when you plug it in, you get 0 over 0. And you get 0 over 0 because, as you can see, sine of 0 is 0 plus 0 plus 0 over 0 is 0 over 0. So I'm going to go ahead and apply L'Hopital's rule. And L'Hopital's rule, you're just going to find the derivative of the numerator and the denominator. So the derivative of sine 2x is 2 cosine 2x. Derivative of ax cubed is 3ax squared. Derivative of bx is just b. And the reason why is I'll show you how just by giving an example. So say you're asked to differentiate 7x, and that would just be 7. So say you're asked to differentiate bx, it would just be b. The reason being is that b is a constant. And then the derivative of x cubed is 3x squared. So from here, you can go ahead and plug in 0 to check if you're going to get an answer or if you're going to get an indeterminate form. So when you plug in 0, you're going to get cosine of 0, which is 1. 1 times 2 is 2. So you're going to get 2 plus b. So here, you can go ahead and solve for b by setting 2 plus b equal to 0. So that right there, b equals -2, would be your first answer. Let's go ahead and continue with our problem, except this time, let's just rewrite it and plug in b, and then we're going to go ahead and do the whole process again, but this time let's find a. All right, so if you plug in 0, you're going to get 0 over 0 again. This is indeterminate form, so you can go ahead and apply L'Hopital's rule. So again, I'm just going to find the derivative of the numerator and the denominator. So I'm going to go ahead and plug in 0 and see if I can get another indeterminate form. If so, I'll apply L'Hopital's a second time. So 2 minus 2 over 0 is going to give me 0 over 0. Indeterminate form. So I'm going to go ahead and apply L'Hopital's a second time. So the derivative of 2 cosine 2x is negative 4 sine 2x. The derivative of 3ax squared is 6ax. The derivative of a constant is 0. Derivative of 3x squared is 6x. Here, I'm going to go ahead and plug in 0. So sine of 0 is 0. And then I'm going to get 0 over 0 again. So this is indeterminate form. So I'm going to go ahead and use L'Hopital's rule. Oh, it's spelled indeterminate. Indeterminate form. So I'm going to go ahead and find the derivative of the numerator and the denominator for the third time. And that's going to give me 8 cosine 2x plus 6a over 6. And I'm going to go ahead and plug in 0. So cosine of 0 is just 1. So negative 8 plus 6a. So this is what we're going to get. And at the beginning, it's showing us that this entire expression is equal to 0. So what we're going to do is that we're going to set this right here equal to 0, and that will let us solve for a. So negative 8 plus 6a over 6 is equal to 0. Oh, you only need to set the numerator equal to 0. So that's just going to give you 4/3. So this right here is our value for A. Thank you for watching.